So the next type of the cell, machine cell, is also called as a flexible manufacturing system. A flexible manufacturing system is very important in nowadays. Why it is important? First of all, let us understand the concept of flexible manufacturing system. It is a production method that is designed to adapt the changes in the type and quantity of product being manufactured. So once again I am reading this statement. A flexible manufacturing system is a production method that is designed to adapt changes in the type and quantity of the product being manufactured. So machines and computerized systems can be configured to manufacture a variety of parts and handle changing levels of production. Now we will discuss this concept a little bit ahead. So in flexible manufacturing system, we can make the changes in the production process very easily. We can make the changes in the quantity of product being manufactured. For example, you want to manufacture 1000 component and suddenly it is decided to reduce the quantity of manufacturing. So you want to manufacture 600 component instead of 1000 components. So in that case you can reduce the quantity of manufacturing, and vice versa. Instead of 1000 components, now you want to manufacture 2000 components. That changes you can do very easily. So underline this word, changes, very easily. Because of changing the system very easily, it is called as a flexible manufacturing system. This is very important in manufacturing process nowadays. Now what it consists of, these points also we will see now. It consists of several flexible automated machine tools which are interlinked by automatic material handling and movement system. In flexible manufacturing system, obviously number of machines are interlinked together by automatic material handling system and movement system. So obviously it is required. One thing you understand, whenever you want to reduce the time of manufacturing, you want to increase production rate, you need to reduce the time of material handling. This is very important step, very important parameter in manufacturing process. In manufacturing process, two machines are interlinked by a vehicle path. For example, you want to transfer one raw material from one machine to the another machine. There is a path between two machines which is defined, and through this path automated guided vehicles may transfer the raw material, or conveyors are used to transfer the material. So material handling system is fully automatic in case of flexible manufacturing system. Then and then only it is possible to make changes in flexible manufacturing system very easily. Later on we will discuss one diagram. It can handle wide variety of dissimilar parts. So underline this word, dissimilar parts. See, we have seen the types of automation probably in last lecture, I think. Fixed automation, soft automation, and this is a flexible type of automation. So in one setup you need to manufacture wide variety of products. आपको अलग अलग प्रोडक्ट्स मैन्युफैक्चर करने हैं, और वो जो प्रोडक्ट्स है उनके फीचर्स बहुत अलग है, उनका साइज अलग होगा, उनका शेप भी है वो भी अलग है. तो अलग अलग शेप साइज के कंपोनेंट जब आप मैन्युफैक्चर करते हो तो उसके लिए आपको सेटअप में फिर से चेंजेस करने पड़ते हैं, एंड दैट प्रोसेस इज वेरी टाइम कंज्यूमिंग. So in flexible manufacturing system, this case is avoided. You can manufacture wide variety of parts, dissimilar parts. The word is used, dissimilar parts. It means that their characteristics are different. Manufacturing operations related to that products are different. Size is different, shape is different, etc. And you can do the manufacturing in flexible manufacturing system. So wide variety of dissimilar parts you can handle. This is very important in FMS. And producing them in small numbers, even one at a time in a random. Say if there is a manufacturing of, say, a shaft, you are manufacturing a shaft, and that shaft is a solid shaft. Now you want to manufacture hollow shaft instead of solid shaft. You can easily go for that, and randomly you can go for that. If you have decided to manufacture 1000 solid shaft and suddenly there is an order of manufacturing hollow shaft, you can directly go for that thing also. So this is greatly possible in FMS only. I am repeating my sentence. This is only possible in FMS only. You can suddenly put a different type of component in manufacturing process and you can manufacturing it. So you can break the link of previous manufacturing part and you can insert new part and you can manufacturing. तो ये जो सिर्फ होता है वो फ्लेक्सिबल मैन्युफैक्चरिंग सिस्टम में ही होता है. अगर आप नट मैन्युफैक्चर कर रहे हो तो उस प्रोसेस के बीच में आप बोल्ट्स भी मैन्युफैक्चर कर सकते हो. सो FMS अलाउज यू टू चेंज द टाइप ऑफ प्रोडक्ट एट एनी टाइम randomly. So therefore sometimes flexible manufacturing system is also called as a random flexible manufacturing system. Because of these characteristics, flexible manufacturing system is also called as a random flexible manufacturing system. Another property of flexible manufacturing system is that this system is able to respond quickly to any changes required. Suppose you want to interchange some machines, you want to interchange some tools, you want to interchange some gauging devices or any kind of manufacturing facilities which are required during manufacturing process. Easily you can change them, and these changes will be only beneficial for manufacturing system. These changes will not make any kind of manufacturing loss. This is also property of FMS. Obviously flexible manufacturing system is very costly. See, flexible manufacturing system is not just a manufacturing process, it is a complete management related to manufacturing process. So please understand this. You can do any change in the system very quickly. As I told you, you can manufacture solid shaft instead of hollow shaft, you can manufacture hollow shaft instead of solid shaft. You can do it very easily and quickly you can do it. So this easily and quickly, and also these changes will be definitely beneficial to FMS. तो ये आपको ध्यान में रखना है कि FMS जो है वो वाइड वैरायटी ऑफ प्रोडक्ट्स मैन्युफैक्चर कर सकता है. वो FMS कौन सा भी मैन्युफैक्चरिंग में जो चेंज होता है वो भी अडेप्ट कर सकता है, और उसमें जो मटेरियल हैंडलिंग सिस्टम है, मटेरियल का मूवमेंट सिस्टम है, वो भी ऑटोमेटिक होता है. अभी एक डायग्राम जो है वो हम देख रहे हैं. Now in this diagram you can see these are the different machines 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Almost there are 12 machines, and these machines are interlinked by this path. So these lines you are watching here, oval type of lines, these lines are paths. We can call it as a vehicle track. These vehicle tracks are used for transportation of raw material from one machine to second machine to third machine to fourth machine. Why these vehicle tracks are there? Because you can fastly transfer the material from one machine to the another machine, and these stations are used to load the raw material to unload the finished product. Is for example, from machine number 1 raw material is loaded, it will go to 2, 3, 4 and so on up to 12th number machine, and then it is unloaded. So this is just one layout which shows the picture of a flexible manufacturing system. Now here you can see there is a computer room where the computers are located for executing different part programs to operate each and every machine. There is a tool room which stores different types of tools required in manufacturing process. There is an inspection room which inspect proper execution of manufacturing plan. So inspection room, tool room, these are having different functions, or which plays, I will say, very important role in manufacturing process. See, basically you can see this chart is this chart represent DNC, that is direct numerical control system. This chart represents direct numerical control system. There is only one computer room, and which is used to operate all types of machines or machine tools. So flexible manufacturing system, in short, we can understand it is heavy but it is flexible, it is costly but it is efficient. This is the specialty of flexible manufacturing system. See, if you visit any kind of automobile industry which manufactures the different parts of automobile, there you will observe flexible manufacturing system. See, I am not talking about complete vehicle manufacturing. I am talking about manufacturing of all parts, different parts, parts of shock absorber, parts of rear axle, front axle, or different small gearboxes, different small gears, types of gears. So there is a variety of product in a single automobile. So these can be manufactured by using flexible manufacturing system. See, most of the time there is a question in the examination. If you observe of previous year question papers, you will see this question: explain flexible manufacturing system with an example. So you need to draw the diagram. This is just a diagram, a schematic diagram for understanding concept of FMS. So FMS, you shortly just remember this. FMS is a fully automatic. It is a flexible, obviously wide variety of products you can manufacture in FMS, and you can do any kind of changes in this manufacturing system. Suppose you want to move the second number machine to the fourth number machine, you can do it easily. So there are many advantages as you can understand from this concept itself. So I request you to go through the YouTube lecture once again and watch it again and again, so you can write in exam properly. So in examination I require this diagram with proper nomenclature. So thank you very much for listening this concept. So in the next lecture we will go through the CAPP, computer aided process planning. Thank you. So this is the bit from chapter number 4, that is part families. Actually it is a sub bit of group technology. So under group technology, part family is one concept, and it is very important in mass production. Whenever you want to manufacture components more than 5,000, more than 6,000, you need to divide these parts by considering their characteristics. A part family can be defined as the group of parts or components having same or identical attributes. So underline this word, having same or identical attributes. Parts may not be exactly same, but they are very close. Parts may not look like same, but their manufacturing process can be same. It means that shape of the component may be different, but the manufacturing operations in this manufacturing process are same, somewhat same, and these parts can be grouped together to simplify the manufacturing process. So that is what part families. So in group technology, part families plays very important role to save manufacturing time and to increase the production rate. तो यहाँ पर आपको बहुत सारे पार्ट्स होंगे, तो वो पार्ट्स मैन्युफैक्चरिंग ऑपरेशंस के बेस पर आपको अलग अलग करने हैं और उनका एक ग्रुप तैयार करना है. तो वहां पर आपको जो भी मैन्युफैक्चरिंग प्रोसेस होगी, वो मैन्युफैक्चरिंग प्रोसेस जो है वो सिंप्लीफाई होकर वहां का जो प्रोडक्शन रेट है वो बढ़ सकता है और मैन्युफैक्चरिंग प्रोसेस का टाइम जो है वो टाइम भी कम हो सकता है. इसके लिए ही पार्ट फैमिली का जो कंसेप्ट है वो ग्रुप टेक्नोलॉजी में इंक्लूड किया है. You can see this diagram here. There are almost 11 components, and these components are divided on the basis of their manufacturing process. You can see this first column, second column, third column. Their manufacturing operations are almost same. Shapes are quite different. Shapes are not same. Shapes are almost different. So mostly in manufacturing process, manufacturing operation is the first parameter to group the components. Suppose you are manufacturing a solid shaft and you are manufacturing again hollow shaft. In both type of manufacturing there is a turning operation. In both type of manufacturing there is a turning operation. So these two components are grouped together. So manufacturing operation is a first parameter to separate the components and take them into the group. अगर वो components के shapes similar है तो सिमिलर शेप्स के भी ग्रुप आप बना सकते हैं, लेकिन उसको आप सेकंड प्रायोरिटी दोगे. यहां पर आपको मैन्युफैक्चरिंग ऑपरेशंस की लिस्ट तैयार करनी है और मैन्युफैक्चरिंग ऑपरेशन की लिस्ट के तौर पर ही आपको वो जो कंपोनेंट्स है वो ग्रुप करने हैं. दिस इज वेरी इंपॉर्टेंट पॉइंट. अगेन एंड अगेन आई एम रिपीटिंग. नाउ व्हाट इज द एडवांटेज ऑफ this part families? You can see here this diagram. See what happens. There are 3 lathe machines you are observing on the screen. First of all, components travel from this lathe machine to this lathe machine. Then it comes to drilling machine. Then it comes to grinder, and then it goes to assembly. Similarly, if you see this drilling machine, component moves from this drilling to this drilling machine to this grinding machine to this assembly. So this way traveling of the product happens. Similarly, if you consider use of this lathe machine, then components travel to this drilling machine, from this drilling machine to this drilling machine, then it goes to grinder, and then it goes to assembly. So arrangement of machine is so much complicated, and traveling time of the component, it is making loss of time in manufacturing process, and it results in reducing the production rate. This is a process layout. Now let us see another process layout. You can see here. Now this is a simplified and schematic process layout. Lathe machine, then drilling machine, then grinding machine, then assembly, and then storage point. Similarly, lathe machine, milling machine, drilling machine, grinding machine, assembly, then storage point. So machines are arranged in such a way that group of components will be subjected to same type of manufacturing operations. So component from lathe machine, it doesn't need to travel from this point to this point. There your objective is to save the time of manufacturing, so that machines are organized in sequence of manufacturing. Machines are organized in order to follow the sequence of manufacturing. You can observe from this diagram. So this is the advantage. So one part family will go through this sequence, second part family will go through this sequence, third part family will go through this sequence, and similarly it will go through this sequence. So according to the part family, machines are arranged, machines are organized according to the part family. Now let us see the advantages of a group technology. In short, I will say advantages of part families. Design: reduction in number of drawings, reduction in time to identify the drawings, easy modifications of design. These are the advantages. Reduction in number of drawings, it indicates that suppose you have drawn one model in the KTA software, and in the second time when you get an order for design, you need to just open that drawing and you need to modify it. आपको जो पहले सेव किया था, जो ड्राइंग था, वो आपको सिर्फ मॉडिफाई करना है. So you don't need to start from the scratch. So ऐसे बहुत सारे मॉडल्स आपके मशीन में सेव हो गए, तो वो जो मॉडल्स है आपको सिर्फ मॉडिफाई करते रहे. Of spur gears in KTA software, and you have saved it in one folder. There may be helical gear, there may be bevel gear. Likewise, all types of gears you have saved in one folder. So this is a philosophy of part families in case of design. So it is not mandatory that you can implement part family concept or group technology concept only in manufacturing. You can implement this in design. So always don't start from the scratch, just modify whatever available with you. Now next advantage in production planning: reduction setup and production time. Obviously, so whenever you start a mass production, you have to set up all the manufacturing requirements, manufacturing resources. So this setup time is reduced. As you have seen this diagram, only these 4 machines are organized in order to manufacture group of parts. This is the another organization, third organization, fourth organization. Almost 4 types of products you can manufacture in less time. Then reduction in work in process inventories. Inventories का मतलब होता है कि स्टोरेज पॉइंट, number of tools required which is available in stock, number of raw materials, their quantities available in stock. So in this way, many things in the production you need to store, and these are required in process of manufacturing. For example, coolant is also required in manufacturing process. So this is also stocked in inventories, and you can reduce their use by using group technology concept or part family concept. Simplified production scheduling, it means that प्रोडक्शन प्लानिंग जो है वो आपका सिंप्लीफाई हो चुका है. इजी आइडेंटिफिकेशन ऑफ बॉटलनेक्स, देन रिड्यूसेस मैन्युफैक्चरिंग लीड टाइम, दिस इज अनदर एडवांटेज. देन group technology leads to automated process planning and scheduling problem, and it also reduces complexity and size of parts. So these are some advantages related to production planning. Then it reduces floor space requirement for production. In short space you can organize number of machine and you can start manufacturing process. Less material movements, that is material handling process is simplified. Less material handling efforts and more flexibility, these are also advantages. Then less number of defects and rejection, this is also advantage. More precise parts, better output quality, and group technology leads to automated quality control systems. Some other advantages you can take into consideration, like accurate and quick cost estimates, because everything is pre-planned, organized very well, so you can easily estimate the cost of manufacturing product. Then less number of parts and raw material are required in group technology, because rejection rate is low. Rejection rate is not more in group technology. It provides standardization rule for purchasing. Obviously purchase process, it is a different part, but you can go for the standardization rules for purchasing. Limitation is that high cost of implementation. The group technology, obviously you need to organize the machines as per the product requirement, manufacture requirement. So implementation cost is more. Large number of group technology codes you have to follow. See, each part is coded in group technology. It may not be suitable where wide varieties of products are manufactured. As I told you in the start itself, it is required for mass production. Rearranging of machine is very difficult and time consuming process. So in group technology, each part is coded. Suppose there are 100 parts manufactured, each part has a separate code and it's a separate report stored in your machine or in your computer for checking the quality, for going for inspection of that product. So every part has a coding for checking its quality. So these are some limitations of group technology. MRP, Material Requirement Planning. Material Requirement Planning is a system for calculating the materials and components needed to manufacture a product. So once again I am repeating, Material Requirement Planning is a system for calculating the materials and components needed to manufacture a product. So this MRP, this process, actually it depends on the infrastructure of the company. For different infrastructure, for different resources, this MRP process, that is Material Requirement Planning process, it changes. For small scale industry it may be different, for medium scale industry it may be different. So as per the judgment of the production floor or the production sector, MRP is done. But there are some common points which are taken into consideration for Material Requirement Planning that we are going to discuss today. So first of all, let us see Material Requirement Planning. Before going for Material Requirement Planning, you must have the master production schedule. Once again I am repeating, you are seeing this chart. There you can see a master master production schedule. And master production schedule, how it can be done? It can be done with the help of 4 basic plans or 4 basic points. First one is order. How many orders you may have in a future, that is called as a forecast. You can see on the screen, forecast is written. Then bill of material which consists of different raw material calculations, means quantity of material, then requirement of the material availability in the organization, and then inventory, how many resources are stored in a stock. So that is what the inventory. So these 4 points, I am not going in detail, but these 4 points you must take into consideration for preparing master production schedule. So master production schedule, actually it is a vast point. There are a lot of parameters for preparing master production schedule. Here you have to consider also resources available to the production process. That must be also considered. So this is one parameter, but it is very important parameter. You must have the master production schedule on the basis of orders, bill of material, then forecast, and then inventory. On the basis of these 4 points, you must have this MPS, that is called as a master production schedule. And by considering all these points, you must go to Material Requirement Planning. Material Requirement Planning, it consists of basically 4 outputs: purchase orders, then material plan, then work orders, and then reports available to you. So reports you have to generate. Output of MRP is purchase order, obviously, because if you observe that while planning the quantity of material, if you observe that number of raw materials, that is quantity of raw material is less, then you have to put a purchase order. It is a simple logic. If you observe that quantity of material is more than requirement, then you have to plan very specifically for production process. So that is what material plan. This is also output. Then work orders. If according to the number of raw material, that is quantity of raw material available to you, you should put a work orders to the production floor for production process. And reports you have to generate. Reports it may consist of analysis of material utilization, then analysis of material requirement, analysis of available material. All these points which are important to consider in MRP, that you have to analyze properly in order to continue smooth flow of production process. So MRP is important for purchase order, it is important for material plan, it is important for work orders, and it is also important for generating reports. These reports will help us to improve the production process. This is very important point. Now report is actually very detailed. Now we will go ahead and we will discuss about the implementation of softwares in MRP, in automation. Actually, in small scale industry, this MRP is done by using Microsoft Excel. There is no need to go for any kind of advanced software. Microsoft Excel is sufficient for material requirement planning. Their traditional chart is stored in the computer and they are following this traditional chart again and again for years and years to go for the material requirement planning. But there is a plant which manufactures different kind of materials in a day. Variety of materials are manufactured in a day. So there must be use of special purpose software. For example, SAP is one software, SAP. It's the information you will get on youtube.com in detail. But SAP is an advanced software. As per the requirement of the industry, customized softwares. It means that as per the requirement of production process, customized softwares are provided to the MNCs for material requirement planning. SAP is just an example. So MRP, it is different for different industry, but these points we are discussing, these are just common. If you go in depth, the bill of material is also vast point. The bill of material, it consists of almost all material requirement planning, because it consists of every activity is recorded in bill of material movement. The raw material movement, finished product movement, then availability material, all these records are included in bill of material. So it must be considered, and bill of material is also done with the help of SAP software. So these tutorials are also available on youtube.com. You will proceed and you can see for the extra knowledge. So this MRP, why it is important? The very first objective, now we will discuss the objective. Why it is important? Very first thing, production rate should not be hampered. Production rates, suppose one production floor, it is decided to manufacture 100 components in 8 hours per day. Working hours 8 hours, and during these 8 hours 100 components they want to manufacture. It should not be hampered because of unavailability of material or any kind of resources. So this is a very important point to be considered. Then smooth flow of material should happen during production process. Again I am repeating this sentence. Smooth flow of smooth flow of material during production process must happen. Because there should not be a single breakdown during the production process. It should not happen that one machine is there's sitting blankly, there is not a single work happening on that machine for 5 minutes. So that 5 minutes also cost more in production process. in production process, minute and second is also important for increasing the production rate. So final objective of that MRP or bill of material, it is that production rate should not be hampered. So we must be ready in advance before starting the production process. Now output of material requirement planning, it is told that purchase order. In some cases I have observed that initially customer demand is to manufacture only 500 components. Now the customer is asking for more 500 components, means his or her demand is increased. Now what he should do? So in this case, purchase order, we have to place a purchase order for purchasing raw material again. So you must understand this philosophy, and sometimes it may happen your second purchase order for raw material, it may be delayed because of some problems, and there you have to you may stop the production process because of unavailability of extra raw material for second order. So you must be ready for second order also, third order also, and that is all dependent on forecasting during master production schedule. This parameter should be considered during master production schedule, that is MPS, that customer may place extra order, and for this purpose whether do you have extra raw material or not. So this must be taken into consideration. So therefore purchase orders are placed in advance. Then work orders. So if you want to manufacture 500 components for this particular delivery of the customer, whether you have raw material availability or not, see again I am telling the same thing, but work order must consist of quantity of raw material is delivered to production department, and they must manufacture all these products on the basis of quantity of raw material provided to them. So this parameter they should consist of. So work order, it is not just like that you manufacture 500 component. It is a detailed explanation of how you have to proceed for manufacturing process. Again I am reading, it consists of detailed process how you have to proceed for manufacturing process. For example, work order will consist of drawing, machine drawing, product design. It will consist of plan of manufacturing. It will consist of quantity of raw material which is provided to you for manufacturing. It will consist of different gauging devices and required resources available to you for manufacturing process, human resources, etc. So all these things are included in work orders, and that is happening only in the organization. So this is important. Then reports, as at the start itself I discussed with you what it consists of. It consists of detailed record of material movement, whether it is utilized or not. Because of a late entry of material in the production process, there may be a delay in manufacturing. This kind of activities also recorded in reports. So these reports are helpful for improving a production process. Again I am repeating, these reports are helpful for improving production process. Just example we will discuss. Suppose it is observed that one material travel from one machine to the another machine, and it takes a span of only 15 to 20 seconds. 20 seconds we will consider. So for increasing the production process, it is decided to have a minimum travel time for ट्रांसफरिंग प्रोडक्ट रॉ मटेरियल फ्रॉम वन मशीन टू द अनदर मशीन. अगर आपको एक प्रोडक्ट एक मशीन रैपिड प्रोटोटाइपिंग, actually rapid prototyping nowadays it is also considered in computer aided design, and also it is considered in computer aided manufacturing. So in computer aided design, rapidly a scaled model of a physical part is generated. Once again I am repeating, a scaled model of a physical part is generated in rapid prototyping. So in computer aided design, we can generate a design or a model of any part rapidly. We can generate design or a model of any part rapidly. Therefore, you can call it as a rapid prototyping. See, nowadays it is not possible for quick development of prototype physically. 3D printers are also available in the market for generating the prototypes. Prototype, it means a scaled model. But 3D printers are also not so fast. They can generate the scaled model, no issue, but their speed is less. But at least you can generate. This is the good advantage of prototyping. See, nowadays 3D printers are used for generating the prototype because complicated shaped parts. These are very critical to manufacture. These are very critical to generate their dies required for casting. So therefore 3D printing technology is implemented to generate the patterns which are required in casting procedure. So therefore rapid prototyping plays a very important role to manufacture the structures having critical shape. Simply I am repeating the sentence. Rapid prototyping plays very important role in manufacturing of critical shaped components, or I will say irregular shaped components. So there it plays very important role. Now how these rapid prototypes are generated? What is the procedure? So commonly there are 5 steps that we will discuss. That screen is showing the 5 steps. First step you can see, I will zoom now. Creation of a solid model. That is the first step. You can see here in this diagram. Solid model, how it is created? A solid model, it is created by using any CAD software. Any CAD softwares which are available now. You may use CATIA software, you may use ProE software, Unigraphics software, Solid Edge software, SolidWorks software. So these softwares you can use for creating a solid model. For example, you want to create a prototype of a spur gear. So you should draw a solid model of a spur gear in a CAD software, in a computer aided design software. I am specially repeating the word CAD softwares. So you can draw that model. This is the first step. Now next step, it is told that you have to save that model into STL format. Actually, why this STL format is required and why it is generated? Actually, STL format is a stereolithographic format. Once again I am repeating, it is a stereolithographic format. Actually, its a long form is a standard triangle language. Its a format is its a long form is a standard triangle language. But stereolithographic softwares were used in previous days, and at that time this STL format played very important role in rapid prototyping. we have a 3D printer in our college, and whenever you want to go for generating a 3D model, you have to save that file in .stl format, and then you can send that file to the 3D printer, and 3D printer will manufacture, or it will generate a 3D print of that model. 3D print it is just a physical component. It is generated by using different polymers, layer of polymers. So different polymer materials are available in the market. You can use any one, and that will be helpful for generating a 3D component in a software. Now we will see next step. This STL format is available in all CAD software. In previous days it was available in stereolithographic CAD softwares, but nowadays it is available in CATIA, ProE, Unigraphics, Solidase, SolidWorks, etc. In all software it is available. Now in rapid prototyping there is a rapid processing, and it consists of model validity and repairing and slicing. If you find there are some errors in your drawn model or in your manufactured model, final manufactured model, so you have to check its validity, its shape, its dimensions. Then if you find there are some errors, then you have to go for slicing. Slicing it means that it is you can cut unrequired part, or which is not desired in design, you can slice that part and you can remove it, and you can finalize that scaled model or prototype. So this is the function of slicing. In rapid processing, these two steps are important. Very first step is model validity. As I told you, validity, it consists of what? Whether generated physical model is properly scaled or not. For example, there is a spur gear and its size is reduced half, 1:2 ratio. So whether it is happened actually or not, if the shape is if the shape is matching with actual shape or not. So these things you have to check in model validity, and if it does not happen, you have to repair it. Sometimes it is happened that you have to go for 3D printing again and again for achieving the desired prototype. So this also happens because of some problems in 3D printing technology. Now next step we will see rapid prototyping. So you can go for the starting of printing procedure there in rapid prototyping, no issue. But before going for the printing also, you have to validate the model, you have to repair, and you have to slice in the CAD software itself, because slicing functions are also available in CAD softwares, in almost all CAD software. Cut function is there, divide function is there, delete function is there. The different functions are available in different software, but their meaning is slicing. Now next step we will see rapid prototyping. Next step is the post processing, cleaning, post curing and finishing. So if you print any model on 3D printer, you have to go for a cleaning of that model, and this cleaning of the model must be done properly in order to validate its dimensions with the actual physical model, whether it is scaled properly or not. Post curing is also required in 3D printing, and finishing you have to go for the surface finishing of that model. Actually, curing time, you are known about this curing time. You might have studied this curing time in the casting process. Time required for a solidification of that model, that is that called as currying time. So you have seen that currying time concept in casting. So it must be solidified properly, otherwise its shape may change or it may break after 3D printing. So changing of the shape we have to avoid. So we have to give a sufficient time to get that model solidified. Otherwise it should not happen. Model is printed and you have taken it as it is for manufacturing purpose. It should not happen. Give a sufficient time for getting solidified. Its hardness must be maintained during a manufacturing process. And finally you should go for the finishing. As you go for the finishing of the component after forging process, because there are rough surfaces, and in casting process if you are manufacturing a pattern, so your surfaces must be smooth. There should not be a roughness. You have to avoid the roughness, and as per the requirement you should go for the finishing, and that will be a final model. So these 3D printing technologies are very important nowadays during the manufacturing of critical part, and this is a general procedure it is shown here. If you want to manufacture a component, a pattern used during casting process, you can go for the creation of solid model for that pattern here. Then you can convert that solid model to STL file. Then in rapid processing, you can go for the model validity and repairing, and then slicing. Then you can go for the 3D printing of that component by using a 3D printer, that is called as a rapid prototyping. And you can finally go for the post processing of that printed model. You have to clean it, you have to cure it, and you have to finish that model. So this is a common procedure in 3D printing technology. So the rapid prototyping, indirectly we will call it as a 3D printing technology. Nowadays it is available. The 3D printing, it is possible because of CAD softwares, because you have a scope to draw a critical shaped components within a short period of time. Very less time is required to draw a critical shaped or assembly components or separate components, part design, sheet metal design. All these things are very quick nowadays in CAD software, because advanced features are included in this CAD software. So because of this, you can go for the rapid prototyping, and then you can go for the manufacturing of the component. So this is a concept of rapid prototyping. I have tried to explain in a short way. Actually this is a very vast topic. You can see this rapid prototyping in manufacturing sector, and you can go ahead with the different technologies available in manufacturing, but the basic step is rapid prototyping. Obviously its advantages that time required for manufacturing process less, for design process it is less, critical shaped components can be manufactured. These are the advantages of common advantages of rapid prototyping.